Hello and welcome back to Introduction to Physics. My name is Paul Eric and I teach physics, astronomy, and geology at Ozarks Technical Community College in Springfield, Missouri. And today we want to do a review of lessons 14 through 19 for your lecture exam. So no new material today. We're just going to review these lectures. So we're going to begin with lesson number 14 on vibrations and waves. So remember to look at these lesson objectives and then read out of your textbook chapters 19, section 1 and section 2, and then chapter 20, sections 5 and section 6. So the first thing that you need to know for the exam is what is something that is oscillating or something that is vibrating. So you ought to be able to give me two examples of things in nature that either vibrate or oscillate. Okay, then we had a whole bunch of definitions. So we had what frequency was, and you should also know what its abbreviation is, and you should also know what the unit is for frequency. You should be able to calculate the frequency if you know the number of times that something oscillates back and forth, and you know the amount of time it takes it to do it in. Okay, then we talked about what the period of a vibration is, what its symbol is, and then what its unit is, and then you should be able to calculate the period of a vibration if you know the frequency of the vibration, or if you know the frequency of the vibration, you should be able to calculate the period of the vibration. And then the next thing was amplitude. So know what the amplitude of an oscillator is, so that if in the case of a spring, it's going to be how far you stretch the spring before you let it go. But in the case of the pendulum, it's going to be how far out that you pull it. That's going to be the amplitude of it. Also, if I was to give you a graph of something that is oscillating, could you identify on that picture what is the amplitude of that wave? Okay, so be able to do that. Okay, and so here are some sample questions that illustrate these concepts. Okay, then you are not going to have to do anything with Hooke's law. So this is not going to be on the exam. And you're also not going to have to calculate the spring constant. Now you should know what the spring constant is. So the spring constant is a representation of the stiffness of the spring. So the stiffer a spring, the greater its spring constant is going to be. But you're not going to have to calculate it mathematically. So that's what this sample question does. We did this in lab. So we're not going to do this on the lecture exam. But you should be able to calculate the frequency of either a pendulum or the frequency of a spring. And so here are two equations. So the first one allows you to calculate the frequency of a pendulum if you know how long the pendulum is, so that's the L, and if you know what planet you're swinging it on, so that's the G. So G is a fundamental constant to Earth, and it's going to be equal to 9.8 meters per second squared. Okay, so that's what the little g thing is. So practice this at home, being able to solve that equation either for the frequency, or I might have you solve it for the letter L. So make sure you can do the algebra on it. The second equation allows you to calculate the frequency of a spring if you know its spring constant and if you know the mass that is being attached to the spring. So be able to use that formula to calculate the frequency, or be able to rearrange the formula and then solve it for the mass, or rearrange the formula and solve it for the spring constant. So be able to use that equation. And so here are some sample questions that will show you how to do that. Okay, then we talked about the energy of a spring or the energy of an oscillator. So energy E is going to be equal to 1/2 the spring constant of that particular spring times the amplitude squared. So how far back you pull a bow, that's R. That's also going to be the amplitude. So that when you release it, that arrow is going to have a certain amount of energy depending on how far back you pulled the bow. So you should be able to do a problem like this, in which I tell you how far back it's being pulled, and then you tell me how much does that change the energy. Okay, then we talked about what is damped harmonic motion. So again, I could give you a picture like this, and I could say that this is undamped harmonic motion. How would the picture look different if it was damped harmonic motion? And so the amplitude would get smaller, so that instead of going up to here, maybe it's going to go to there. So instead of going down to here, maybe it's going to go to here. Now it's still going to cross at the same point. So it's still going to cross here, and it's still going to cross here. But what we need to do is to make a dotted line and make the amplitude keep getting smaller and smaller. So that's what we mean by damped harmonic motion. You should also be able to explain why. So why does the amplitude get smaller and smaller as time goes on? Okay, I'll let you research it, make sure and be able to answer that question. And then we did forced harmonic motion, and notice it's this picture, but it's reversed. So notice that the amplitude is getting larger and larger as time goes on. And this is going to happen because every object, whether it is a building, or it's a glass, or it's a bridge, every object has a certain frequency that it wants to vibrate at. So even this piece of glass that's in front of me, if I was to hit it, it's going to vibrate at a certain frequency. That's its natural frequency that it wants to vibrate at. So now if I was to shake the piece of glass at that frequency, the amplitude would get larger and larger and larger until finally it would break the glass. So be able to explain what forced harmonic motion is, and then what is resonance. All right, so that takes care of our review for this lesson. So take a break. When we come back, we're going to do our next lesson that's going to be on the Unit 2 exam.